Hello and welcome to this quick run through on some of the uses and the meanings behind some of the vector stuff that is in Crayta. So there's a much longer tutorial that I've done about how to use vectors in game dev and what they mean. And this is just going to be a quick whistle-stop tour of that kind of logic and how you might want to use it. So a vector is essentially a list of numbers, and in game development we use vectors to describe things like the position of objects. So you can see this locator A, which is positioned here. The position is 200, 200, 0. That position is a vector. And the first number is its position on the x-axis, which is this red arrow. Second one is the green arrow, which is the y-axis. And the third one is the z-axis, which is the blue arrow up and down here. Now, if I move this locator in the direction of the red arrow, you'll see that the numbers in the first column of the position increase. So we are increasing the x value of the position vector. Likewise, we can increase and decrease the y value in the position vector, and the same with the z. Now, vectors are really useful for describing position, but they are also really useful for describing the relationship between 2 points. So you can see I've got this point B over here, which is in a different location from point A, and we can get a hold of the vector, which is the line between these 2 points, simply by leveraging the Lua API to take one vector, one position from the other. So by taking position of A from position of B, we now have a vector AB, which describes the relationship between those 2 points. Now, that's quite an abstract concept, but we can actually use that and we can apply it in game development to do some interesting things once we have that vector. So further down, you can see that I'm using the user position and a robot position to get hold of the vector between user and robot. So there's a robot here, and the user is going to be me. Once I have that vector, I can do things like set forward, which will turn that robot's forward-facing direction, and you pass in a vector for that. So if I pass in the vector between the user and the robot, that robot will now constantly face me. And if I want to, I could also give it a velocity, so I can actually get it to walk towards me. And all I will do there is I'll simply use, for now, I can use the same vector to give it a velocity. So now it will constantly be moving towards me. But one thing to notice is that the further away from the robot I get, the faster it will move. So it's not a consistent speed. If I want the consistent speed, so a maximum speed for this robot to move, I will need to use a normalized vector, which is essentially the vector itself with each number in the vector divided by the length of that vector. So for vector AP, it would be the same thing, x minus x, y minus y, a minus z minus z. So it'd be the difference between those over the top of the length. So it will give us the numbers x, y, and z as a percentage, which means that they're a number between 0 and 1, regardless of how far away that is from the points are from each other. So when you then have those numbers as a percentage, that means that you only have the direction and you don't have the scale of the vector, which we can use to set our speed. So we have, let's get normalized vector user robot, and let's do vector user robot normalize. So we're leveraging the Lua API in Crayta at this point. So we're getting the normalized vector user robot, and then we can use that here. So if I just run the game now, you'll see it moves very, very slightly because that's a number between 0 and 1 that it's moving. In fact, it's not really moving at all. So let's multiply it by the speed we want the robot to move. So if we want the robot to move at the speed of 100, then we put in the number 100. And no matter which direction I am from the robot, it will move in, it will have the velocity of 100. I can make it much more scary by setting it to the speed of 1,000, which could also slightly break the game, but now I've got this very, very homing robot. So it's nice to sort of tweak this number and set it to what you need it to be. So that's quite interesting. Another thing we could do is we can check the distance between the user and the robot in a conditional statement. So we can say if, and then we use our vector user robot, and we can get the length of that just simply by running this length function. So if the distance between the user and the robot, regardless of which direction they are from each other, if the distance is less than 500, then, and that's when we can actually get the robot to face the user and start moving the robot towards the user, perhaps. So now the robot's stationary, and only when that distance between us is less than 500 will it actually look at me and start moving towards me. Notice that the actual position of the robot, the Z is in a different position from the user's Z, so it's hovering around. If I manage to run away from it, it will go back to stationary, although the velocity will continue to be 0. So you might want to do like a else. Set the velocity to 0. So we can create a 0 vector simply by doing vector.0 here, which will mean that the robot only moves when it's close enough to me to know where I am. As soon as it doesn't know, it will deactivate. There we go. So that's some vector stuff you can do in a nutshell. You could also try using the vector, the normalized vector, and an amount to apply impulses to physics-enabled objects and see where that gets you. I show that in my longer tutorial video. And if you've got any questions about this stuff, or you get stuck, or you make something awesome using some crazy vector maths, then please drop us a line on the Discord or get in touch on the Discord and shout about what you're making. And if you get stuck, feel free to @me and I can help you out with any of the coding problems you may have. I look forward to seeing what you make with some of this vector stuff in Crayta.